This is Apollo Control at 41 hours. Everything continues to go well aboard Apollo 13 as the three crewmen begin the 5th hour of their scheduled 10-hour rest period. Apollo 13 is 147,103 nautical miles from Earth, traveling at a velocity of 3,960 feet per second. This is Mission Control, Houston. This is Apollo Control at 42 hours. Apollo 13 is now 149,375 nautical miles from Earth. Velocity 3,903 feet per second. The crewmen are at the midpoint now of their 10-hour rest period. That rest period due to end about 47 hours elapsed time. This is Mission Control, Houston. This is Apollo Control at 43 hours. 4 hours remains in the Apollo 13 crew's rest period. Spacecraft is 151,625 nautical miles from Earth, traveling at a velocity of 3,847 feet per second. The Flight Dynamics Officer has again updated the expected S4B impact time and coordinates. We're predicting S4B impact at 77 hours, 57 minutes, 9 seconds. Coordinates of the impact location on the moon, 2 degrees, 11 minutes south, 28 degrees, 58 minutes west. Newsmen in the news center can see the impact point in relationship to landing zones on the monitors in the news center at this time. This is Mission Control, Houston. This is Apollo Control at 43 hours, 17 minutes. 3 briefings on future programs are scheduled this morning in the briefing room at the MSC News Center. Topics and times are Space Station at 9 a.m., the Space Shuttle at 10 a.m., and the reusable space tug at 11 a.m. All 3 of these briefings will be conducted in the briefing room in the MSC News Center. This is Apollo Control at 43 hours, 42 minutes. Apollo 13 is 153,172 nautical miles from Earth, traveling at a velocity of 3,809 feet per second. 3 hours, 17 minutes remains in the crew's rest period. Astronaut Joe Kerwin is the Capcom now. This morning's briefings on future programs in the MSC News Center will be carried on this release line. The first one begins in about 5 minutes at 9 a.m. Central Standard Time. The topic of that briefing is space stations. This is Mission Control, Houston. This is Apollo Control at 44 hours, 42 minutes. Apollo 13's distance from Earth now is 155,370 nautical miles. Velocity is 3,756 feet per second. And 2 hours, 17 minutes remains in the rest period. Mid-course correction number 3 will not be required. Because of this, the plan now is to move the LEM activation time and the TV transmission time from the 58 hours under the plan with a mid-course back to 55 hours. LEM activation and the TV transmission time will now be at 55 hours elapsed time. That's about 8:13 p.m. Central Standard Time this evening. The next briefing in the MSC newsroom will begin in approximately 5 minutes. The topic will be space shuttles, and that briefing will be carried on this line. This is Mission Control, Houston. This is Apollo Control at 45 hours, 47 minutes. Crew wake-up time is 1 hour, 12 minutes away. Apollo 12 is 157,720 nautical miles from Earth. Its velocity is 3,701 feet per second. The 11 a.m. briefing on reusable space tug will be carried on this line. This is Mission Control, Houston. This is Apollo Control at 46 hours, 43 minutes. Spacecraft Commander Jim Lovell has just put in a call to us 16 minutes prior to wake-up time. Here's that conversation.
Okay, I think if we get in a few minutes, we're bringing out some food, and we'll copy the plan.
Okay, and Surgeon will be ready for your sleep report whenever you get that together.
Right, he's listening. LMP had a solid 9 hours of sleep. I couldn't wake him up this morning. CMP had 6 hours, and the commander about 5 intermittent. Jack's dosimeter is reading to 02026.
Okay, we got it.
Sure looks like it.
And it might be interesting that just after we went to sleep last night, we had a master alarm, and it really scared us. And we were all over the cockpit like a wet noodle.
Sorry it wasn't something more significant. I've also got a procedure for you on that H2 tank. Simple thing after you get done stirring up the cryos.
Okay.
That was beautiful. What was it?
A little with their eyes on the star for wake up.
like all the comforts at home. Have you guys got a flower on your breakfast table?
Yeah, Jack.
The Capcom is astronaut Joe Kerwin. With him at his console is the backup crew commander John Young. Apollo 13 is 159,967 nautical miles from Earth, velocity 3,649 feet per second. The flight dynamics officer has again updated the S-4B impact time and location. Impact time 77 hours 57 minutes 5 seconds. Coordinates 1 degree 54 minutes south, 28 degrees 47 minutes west.
Houston, Apollo 13, over.
13, Houston, go ahead. This is Houston, go.
Roger, Joe. We're standing by for that P-37 block data if you have it for us.
Okay, got it right here, Jim, and it follows. This is the P-37 pad for liftoff plus 60. The reason for the update is for weather avoidance in the MPL at 119 hours. Same as the one we passed you yesterday, and it's the same weather, but we still don't expect a problem at the end of the mission. GETI is 06000. Delta VT 6079er. Longitude -153. GET 400K 11804. Over.
GETI of 06000 6079 -153 11804.
Roger, that's correct. I've got a consumables update for you, Jim, if you're ready for that.
Ready, copy.
Okay, as of 47 hours, RCS total 10906, Quad Alpha 270, Bravo 278, Charlie 270, Delta 278. And the H2, they gave me the H2s in percent, 76%. And on the O2 we have 81%. However, we show the O2 tank 2 reading off scale high now. We're quite sure it's a sensor failure. We'd like you to verify it with your onboard reading.
Okay, stand by. Joe, we confirm our gauge reading is the number 2 O2 tank is reading off scale high now, but Jack just tells me that it was okay when he first looked at it this morning.
We verify that. At 46:45, we had 82%, and apparently when he stirred the cryos, the sensor broke.
Okay.
So it's no problem. You're above nominal on all your consumables. On the H2 tank problem, we have a procedure that we'd like you to carry out, which is simply turning the H2 tank 2 heaters to off at this time. And we want to see whether that won't solve the problem of the tank pressure setting off caution and warning. We want to look at it that way for a few hours.
Okay, you want both H2 tank heaters to off, is that correct?
That's negative. Just tank 2. We want tank 1 to stay in auto.
Okay, tank 2 heaters off at this time.
Okay, good deal. That's been the high tank, and apparently while waiting for that pressure switch to close to start the heater cycle, the tank 1 pressure has been dropping even a little bit lower and just setting off caution and warning. So we feel that if we turn off the tank 2 heater and let tank 1 activate the heater cycle, we won't get into the caution and warning range.
Roger.
Okay, Jim, at your convenience, we'd like to and accept. We're ready to uplink you state vector now, since we will not do mid-course 3. Over.
Roger, you're in and accept, no mid-course 3, and we're all set for state vector update. I'll give you the LEM CM P here shortly.
Okay, good deal. And I have flight plan updates for you later, at your convenience.
Houston, Apollo 13, the LEM CM Delta P is 1.0 PSI.
Copy 1.0, Jim.
Houston, the 13, we're ready for any flight plan updates that you have.
Okay, 13, to start off with, I've got a minor procedural change for Jack on his next P-52, if he's ready to listen to that.
Okay, Jack's still off comm. We'll hold off on that a little bit, and then we'll pick it up when he gets on comm.
Okay, fine. I've got 2 updates for you, Jim. One is a procedure for looking for Comet Bennett at about 49:45, and I'll wait till Jack gets up before passing you the details on that. The other update is concerned with going into the LEM 3 hours early. And I think Vance mentioned to you last night that this was a possibility, that we'd like to look at the sheet tank pressure early, and since we're not going to do mid-course 3, we'd like LEM entry at 55 hours. Is that okay with you?
Okay, well, right, that's fine with us. We'll move up LEM entry to 55 hours.
Okay, I've got some details on the flight plan for you as follows. Of course, since there's no MCC3, you'll be deleting all the mid-course 3 stuff, including the P-52, which is called out at about 54 and a half, and we'll be slipping that until later, which I'll tell you in a minute. Okay, then we want to move the battery charge up 3 hours to about 52:30. And we want to moving the LEM tunnel vent valve to LEM CM Delta P up 3 hours to 52:45. And at that point, you can simply go to the 57-hour point in the flight plan, change the number from 57 hours to 54 hours, and start through that. In the remarks session, at about 57:50, it says O2 fuel cell purge and wastewater dump here if not performed earlier. We want you to do that at 54 hours and 50 minutes. The TV pass-in will be at 55 hours to 55:30. You'll go right through the... Houston, how do you leave? Houston, you back with us? Apollo 13 Houston, are you back with us?
We're back with you.
Okay, I'd gone through the battery charge, the LEM vent valve, the fuel cell purge, and then stop PTC at 55 hours, and your roll attitude there will be 285 degrees, which is per the flight plan. The high gain antenna angles are slightly different. Pitch 2-3 and yaw 2-6-7 degrees. The TV pass till 55:30. The standard LEM activation, except for some special steps we'll give you to take a look at sheet tank pressure, which I don't have yet. Restart PTC at about 56:30, or whenever you're through with the LEM activities. And after that, at your convenience, we'd like you to do the P52 option 3 that we canceled at 54 and a half hours. Over.
Okay, our last comment was we'll do the P52 after we start PTC at about 56:30.
That's right. Any time after that, it's not time critical.
Okay, let's see if I have some of this, Joe. Around 52:30, we're going to do a battery charge on battery B.
That's correct.
And then about 52:40, we're going to do the LEM tunnel vent valve, LEM CF delta P, which is been written up at 55:40.
That's correct.
We're deleting mid-course 3, and we've moved up LEM entry to 55 hours. So we'll barely follow all the procedure that leads up to LEM entry that was originally scheduled for 58.
That's correct. You can start at 57 in the flight plan, call it 54 hours, and press right on.
Okay, then whenever we're finished with the LEM, which we anticipate around 56:30, we'll commence PTC, and sometime after that we'll do a P52.
That's affirmative. Did you copy the new high gain angles for 55 hours? The ones we
Okay,
have.
we're going to stop the PTC for LEM entry. We're going to stop the PTC for LEM entry at roll 285, and the high gain angles are pitch 2-3 and yaw 2-6-7.
That's correct, Jim. And 13 Houston, the computer is yours.
Computer's ours, we're in block, and exactly when do you want the TV to be cranked up?
You can crank it up sometime prior to 55 hours at your convenience just to set it up. We'll be expecting transmission at 55 hours.
Okay. And Houston, Apollo 13, one thing I missed about the O2 fuel cell purge and wastewater dump.
Roger that. We'd like the O2 fuel cell purge and wastewater dump at 5450.
Roger, we'll do both those items at 5450.
Apollo 13, Houston.
Go ahead, Joe.
Oh, Roger, Jack. One thing we'd like to have done sometime soon is to have you cycle the cryo fans in O2 tank 2 one more time. We'd like to see if we can get that sensor back.
Okay, go on. O2 tank 2, fan on down.
Roger.
Houston 13.
Go 13.
We have just one question. The LEM tunnel vent valve, we're questioning why we're venting until the delta P is greater than 1.7, and we're going to open up the tunnel and pressurize the LEM here shortly.
Right, stand by on that. Houston.
Go ahead.
Roger, the word on that, Jim, is that they want to ensure the proper O2 concentration in the LEM when you get to the surface, and this is a method of doing that by bleeding out additional nitrogen.
Okay, thank you.
And 13 Houston, if Jack is up, I'd like to talk to him about the P-52 briefly.
Okay, he's here.
Go ahead, Joe.
Okay, Jack. What they'd like you to do on this P-52 at 49 hours, they've been observing a slight jitter in the optics shaft angle of about 0.2 of a degree, plus or minus. Before you come out of the optic zero position at the start of this P-52, they'd like you to just observe the shaft readout and see if the jitter occurs on your direct readout there, and also they'd like you to briefly call up a VERP 16 now 91 so we can look at the shaft to trunnion angles.
Okay, let's see if I got it right. On the P-52 at 49 hours, before coming out of zero on the optic, observe the shaft and also call up 1691, let you look at the shaft and trunnion angles to observe a possible jitter and see whether it occurs in the zero position as well as out of zero.
Roger, Jack, that's correct. And if you have time now, I've got a flight plan update for you on looking for the Comet Bennett.
Okay. Stand by one, Joe, and the commander's going off the air briefly.
Roger that.
Okay, Joe, ready to copy that update.
Okay, Jack, I'm going to read it to you and then add some comments, and we'll talk about it a little bit. This should occur sometime after 49:30. After the P-52 realign at 49 hours, if time permits, we would like the crew to investigate while in PTC if there is a roll angle in which the comet can be observed for photos. If there is, record the optimum roll angle for possible photography prior to reinitiating PTC at 56:30 or so whenever the guys are done in the LEM. Use P-52 planet option and the following half-unit vectors for tracking Comet Bennett at about 49:46. Are you ready to copy half-unit vectors over?
Okay, go ahead, Joe.
Okay, R1 plus decimal 34202, R2 minus decimal 07374, R3 plus decimal 35719. Read back.
Okay, copy R1 plus 34202, R2 minus 07374, R3 plus 35719.
Okay, that's correct. And the last sentence on the update is that you can expect AOS of the comet at a roll of 45 degrees and LOS at a roll of 155 degrees. Now the deal here, Jack, according to the plots they showed me, is the comet appears to be about 10 degrees away from the sun, and due to the geometry of the LEM there shadowing the sun, it would appear that you will be able to see the comet through the sextant without getting sun shafting between roll angles of about 45 degrees and 75 degrees. It appears that as your roll gets higher than 75 degrees, although the comet is still in the field of view, the sun is also in the field of view, and you probably will not have any success between 75 and 155 if you haven't got it from 45 to 75. If you do find that you can see the comet somewhere between 45 and 75 or 80 degrees. Just note that roll angle, and then if it's feasible, we'd like you to photograph it after the LEM entry part of the checklist. Over.
Okay, Joe, let me give it back to you and see if I've got it here. After the P-52, during our PTC, you want us to use P-52 and observe Bennett's comet through the section. Note a roll angle, if we can find it visible. It should be visible somewhere between, ideally, between 45 and 75 degrees. And we should lose it at about 155 roll. And if we do see it, make an observation of whether it is photographable. Note the roll angle for photographs to be taken after or prior to the initiation of PTC at 5630.
That's exactly right, Jack.
Okay, real fun.
Apollo 13, Houston.
Go ahead, Joe.
We're ready to have the O2 tank 2 fan off, and thank you.
Okay. Doesn't look like we got it back, huh?
No, it doesn't, Jack.
At 48 hours 32 minutes, Apollo 13's distance is 163,513 nautical miles. Velocity 3,568 feet per second. This Apollo control at 48 hours, 48 minutes. In the control center, the gold team, led by Jerry Griffin, is in the process of turning over to Gene Kranz and his white team. We're estimating a change of shift news conference with Jerry Griffin for 2:30 p.m. Central Standard Time in the briefing room at the MSC News Center.
Houston, Apollo 13.
This is Apollo Control, Houston, at 49 hours, 1 minute. Now into the flight of Apollo 13. The Apollo 13 spacecraft.
Hey, 13, Houston, go ahead.
Okay, Joe, I've started into P-52 here. I've proceeded on option 3, and on the 5025 display, I called up 1691. I'm going to let you observe the shaft angle while the optics are still in zero.
Okay, roger that, Jack. We're looking at it, and I'll give you a mark soon as GNC is happy.
That was Jack Schweigert, command module pilot. He's aligning his spacecraft platform at this time.
Uh, 13 Houston, Jack, could you give us a readout on your counter now?
Okay, I'm showing a shaft of 0.2 and a trunnion of 359.92.
Roger, copy that. Is there any jumping around in the shaft?
You mean on the T-Pack readout?
Yes.
As a matter of fact, it went from 0.2 to 0.21.
Okay, copy that. Stand by one.
Okay, now it went down as low as 0.15.
Okay.
Apollo Control, Houston, Apollo 13, now 164,602 nautical miles away from Earth, traveling at a speed of 3,544 feet per second.
Jack, Houston, let us watch that for another minute or so.
Okay, no hurry. It looks like it's bearing between 0.14 and 0.8 with occasional spikes up to 0.2.
Roger. Apollo 13 Houston, you can press on with P-52 now. Over.
Okay, go.
It's Apollo Control, Houston. In the Mission Control Center, Gene Kranz is taking the reins of the flight control team. He's sporting a flashy white vest in the best traditions of his team color. Joe Kerwin remains on as our capsule communicator with the spacecraft. We're at 49 hours, 6 minutes into the flight, and Apollo 13 presently 164,698 nautical miles out from Earth, traveling at a speed of 3,541 feet per second. This is Apollo Control, Houston.
Hey, Houston, Are we clear to torque? Are you reading the torquing angle?
Houston, go ahead and torque.
Okay, time of torquing will be 49 hours, 8 minutes, 35 seconds.
Roger that.
This Apollo Control Houston at 49 hours, 9 minutes now into the flight. The change of shift news conference is still estimated, has an estimated start of 2:30. Meanwhile, in Mission Control, Flight Dynamics has updated our S4B impact coordinates and time. We're presently looking at coordinates of 2 degrees, 18 minutes south, 28 degrees, 50 minutes west, at a ground elapsed time of 77 hours, 57 minutes, 5 seconds. Apollo 13 is now 164,814 nautical miles away from Earth, traveling at a speed of 3,539 feet per second.
Apollo 13, Houston.
Go ahead, Houston.
Roger. For Jack, we missed the star angle difference on the P-52. Could you read us that?
Roger, Houston, with all balls.
Okay, thank you.
That was Jim Lovell, spacecraft commander, responding to Joe Kerwin. We're at 49 hours, 11 minutes now into the flight, and this is Apollo Control Houston. This is Apollo Control Houston, 49 hours, 15 minutes now into the flight. We'll take down our air-to-ground line at this time since the change of shift briefing is now scheduled to begin. This is Apollo Control Houston. This is Apollo Control Houston, 49 hours, 32 minutes now since liftoff. Apollo 13 presently 165,573 nautical miles out from Earth, traveling at a velocity of 3,522 feet per second. Since we took the line down for the change of shift briefing, we've had no voice communications with the crew. However, we will leave the line open at this time and stand by and continue to monitor. At 49 hours, 33 minutes into the flight, this is Apollo Control Houston. This is Apollo Control Houston at 49 hours, 35 minutes since liftoff. We're presently looking at a start of limb activation at 55 hours ground elapsed time, and Goldstone will be feeding the television transmission at that time. Apollo 13 now 165,675 nautical miles away from Earth and traveling at a speed of 3,520 feet per second. We're at 49 hours, 36 minutes, and this is Apollo Control Houston.
Okay, Houston, 13.
13 Houston, go ahead.
Okay, Joe, I got into P-52 about 49:34. We loaded the planet, or man-comet vectors into the planet option. And P-52 tracked it all the way across, except that it was always occulted by the left. And we're at a roll angle of 155 now.
Roger, we're copying your roll angles. At what roll angle were you able to start tracking it, Jack?
Okay, at the time we entered it there, we were about 66 degrees roll. So either we started too late or maybe somehow we got a wrong calculation on the roll angle.
Okay, let me have GNC comment on that. I suspect that that the roll angles we gave you were calculated for exactly 90 degrees pitch, and you're probably wobbling enough that they're not exactly correct.
Yeah, I think you probably got the right idea.
Houston, over.
Go ahead.
Okay, Jack, notice you've secured from that, and that was going to be our recommendation anyway. We're going to have the guys in the back room look at it and see if they can come up with some better numbers based on the cone angle that you're traveling through, whether there are any roll angles that are available to you. And if there are, and we have time, we might give it another try. If not, we just will forget it.
Okay.
Apollo 13, Houston, over.
Go ahead, Joe.
Okay, Jack, I'd like to pass you a switch configuration on the cryo O2 tanks and give you the reason. Right now, we'd like you to go to heaters, tank 1 off, tank 2 auto, which is the opposite of the way you've got them now.
Okay, O2 or H2?
This is O2 and stand by for that. Excuse me, this is H2, Jack, H2. Okay, Jack, we're getting you back, and I hope you copied my correction of my mistake. I'm talking about the H2 cryo tanks. We like the tank 1 heater to off, tank 2 to auto. Over.
Okay, we lost you again. Here's our heater configuration now. H2 heaters 1 off, 2 auto. Both O2 heaters are in auto.
Okay, that's the configuration we want you in, and here's what we're thinking about. When we went to tank 1 auto, tank 2 off, we found that the heater cycled at a tank 1 pressure of about 233 psi, which is well above the caution and warning limit. And if we go to that configuration for sleep, we'll keep from getting caution and warning lights during the sleep cycle. Okay, in order to do that comfortably, we want to spend the rest of the day using more H2 out of tank number 2 so as to get an unbalance in favor of tank 1, so at the end of the sleep cycle it'll all come out even. And that's why we have you in tank 1 off, tank 2 auto now. We expect to get about a 3% unbalance over the next 10 hours, and prior to sleep we'll call you to reverse the configuration again. Now the only disadvantage here is that during the day you will probably get a few caution and warnings, and we just figured it'd be better to get them now than while you were sacked out. Over.
I'll buy that 100%.
Okay, good deal. One other detail for you, Jack. GNC tells us that the optics jitter is very similar to what we had on Apollo 12. It's no problem, but when you're not using the optics, we recommend that you turn the optics power switch to off to guard against a possible degradation as the flight progresses. Over.
Okay, will do.
Okay, Apollo 13, Houston, I have one more little update for you, and it's another update to the erasable memory onboard crew charts on page G9-2, over.
Houston, 13, we're ready to copy.
Okay, Jim, these are gyro compensation terms. They've already been uplinked, and we're just updating your onboard charts now. In column A, number 11, change from 77646 to 00114. Number 12, change from 77332 to 77546. Number 13, change from 76617 to 77201. Over.
The changes are as follows. All in column A, number 12. The new change is 77546. Number 11, the new change is 00114. And 13, the new change is 77201.
Roger, read back correct.
And Joe, do you know, are you going to try and let us spot the Bennett comet on this next revolution here? Or do you want me to turn the optics power off now?
Stand by one, Jack. Okay, Jack. We don't have confidence in those roll angles yet. So why don't you turn the optics off, and we'll update you later.
Okay, going off now.
Roger.
This is Apollo Control Houston at 49 hours, 55 minutes now into the flight. Apollo 13 now 166,000 341 nautical miles away from Earth, traveling at a velocity of 3,505 feet per second. What you heard was a relatively long exchange between capsule communicator Joe Kerwin and both command module pilot Jack Schweikert and spacecraft commander Jim Lovell. The auto and off heater positions referred to are the switch positions for the H2 heaters used to control redundant heaters in the two cryogenic hydrogen tanks. We're at 49 hours, 56 minutes into the flight and continuing to monitor. This is Apollo Control, Houston. This is Apollo Control, Houston, at 50 hours, 9 minutes now into the flight. We presently show Apollo 13 at an altitude of 166,801 nautical miles, now traveling at a speed of 3,495 feet per second. This is Apollo Control, Houston, at 50 hours, 25 minutes now into the flight. Our display presently shows Apollo 13 at 167,355 nautical miles away from Earth and traveling at a speed of 3,483 feet per second. We've had no voice communication with the crew for the past 15 or so minutes. However, we will stand by and continue to keep the line open and live. We're at 55 hours, 25 minutes, and this is Apollo Control, Houston.
Apollo 13, Houston.
Go ahead.
Roger, Jim, if you've got a couple minutes now, I'd like to read up to you the change to the LEM entry procedure that we'd like you to observe at 55 hours and the rationale for it. Over.
Okay, stand by.
Roger.
Go ahead, Joe.
Okay, before you start copying, this procedure is basically simply to activate the supercritical helium pressure gauging so that you can read it. And the concern here is lest this supercritical helium pressure reach 1,800 psi by 103 hours, at which point we'd be within a possibility of rupturing the burst disk when you activate the dips. Now, based on the pressure at launch and based on a nominal rise time of about 6.5 psi per hour between then and now, the pressure should read about 710 psi. Stand by. Roger. Based on the the pre-launch pressure in the she tank and a nominal rise time of about 6.5 psi per hour, the pressure should be about 710 for 55 hours. Are you reading over? Jim Houston, did you read that last?
Joe, I'm on Omni C now. How do you read?
13 Houston, you're loud and clear now. Inco tells me he's having a little problem at Goldstone and wants me to stand by for a minute.
Okay, how do you read now, Joe? I'm going from Omni C to D now.
You're still loud and clear on D, Fred. Stand by one.
Okay, I'll put her back to Omni B if y'all want to take command again. And the last thing we heard, Joe, was that the supercrit should be reading about 710 psi.
Okay, that's the last thing I passed up, and while we're waiting for Inco to decide here, let me continue. The dead band that is considered acceptable is between 660 and 770 psi. In other words, any rise time that'll give you a pressure between those two will keep you below the critical pressure at 103 hours or so. So we expect it to read in that band, and if it does, there will be no problem. If it reads between 770 and 800 psi, we will want you to check the pressure again at about 59 hours, and I'll get to detailed procedures in a minute. If the pressure is equal to or greater than 800 psi, we're going to have to go into some more detailed procedures. We're going to try to get PCM data on it, for one thing. We may have to have you sit there and stare at the gauge for a while to find out when it clicks up and get an accurate rise time on it. And in an extreme case, we're even thinking about a dip's burn. But we don't really think that'll happen. Now, if you're ready to copy, what I have for you is a change or an addition to the LEM activation checklist between pages TLC1 and TLC2, which consists of 7 steps. And if you can find a blank side there to write it down, and I'd like to pass it up over.
How do you read on Omni C now?
Okay, you're loud and clear on on Omni-C. Stand by one while we get ANCO synced up.
Okay, the rest of your update was that it's okay if it's anywhere between 660 and 770 psi. If it be above 770, you're going to ask us to consider going back in at 59 hours and either get PCM going or sit there and give you gauge reading changes on the basis of time. And you said something about at an extreme measure, we may have to consider some sort of dips maneuver.
That's correct, Fred. We don't have procedures for that yet, and we don't have any real expectation of getting into it. The procedure I'd like to read up to you now is simply the steps required to get the supercritical helium pressure reading at 55 hours. Over.
Okay.
Okay, we're calling this page TLC-1-A, Step 6. Transfer to LEM power.
Stand by one, Joe.
Okay.
Okay, Joe, he's ready to go.
Okay, Step 6. Transfer to LEM power, parenthesis, floodlights blink, caution warning, power, caution light on. Report GET to MCC. Panel 11, circuit breaker EPS, translunar bus tie, close. Circuit breaker panel 16, EPS, translunar bus tie, close. Circuit breaker panel 11, lighting, utility, close. And activate utility lights. Over. And 13 Houston, select Omni Bravo, please.
Okay, Joe, I created a new page here called TLC-1A, item 6, transfer to LEM power. And the usual, check that the floodlights blink and I get the caution warning power light on. I get a GET from Jack and I'll pass that down to you. Item 7, circuit breakers, EPS, X-lunar bus tie, panels 11 and 16 close. Step 8, circuit breaker lighting, the utility on panel 11, close and turn on the utility lights. However, if the lighting is such that I don't really need those, they're in storage right now, I guess, in the ISA, and I'll probably just leave them there.
Okay, that's optional. The way we have page TLC-1A written, that was all part of Step 6. You haven't even gotten to Step 7 yet. Step 7 is as follows. Fred Houston, are you with me? Apollo 13 Houston, are you reading me now?
This is Apollo Control Houston.
You read.
13 Houston, loud and clear. What Omni on now?
I'm going to stay Omni B if y'all want to take command back, and you can let Info jockey them around between B and D. And how many steps we got so I know that are right big or small there, Joe?
Okay, we got step 6 through 12, but step 7 is the same size as 6, and 8 through 12 are short. They're only one line each.
Okay.
Okay, step 7 follows. Circuit breaker, panel 11, AC bus B, helium, PQGS, propellant display, close. Circuit breaker 11 AC bus B, numeric lighting, close. Circuit breaker 11 AC bus B, bus tie inverter 1, close. Circuit breaker panel 11 EPS, inverter 1, close. Circuit breaker panel 16, instrumentation, SIG sensor, close. Inverter 1.
Hold on a minute, Joe.
Okay.
My shorthand is rather poor today. Okay, I'm now up to circuit breaker panel 11, inverter 1 closed.
Okay, the next was circuit breaker panel 16, instrumentation, SIG sensor, close. Then inverter 1, select. Then helium monitor to supercrit press. Report supercrit press to CC.
Houston,
13, Houston, you're coming through. We still have some background noise. Do you want to read back step 7?
Houston, 13.
13, Houston, go ahead.
Okay, Joe, the last thing I got was helium monitor to supercrit pressure.
Okay, and the last part of step 7 is report supercrit pressure to MCC. And read back step 7.
Okay, step 7, circuit breaker panel 11 AC bus B, helium PQGS display closed. Same circuit breaker panel 11 AC bus B, numeric lighting closed. CB panel 11 AC bus, is that AC bus B, bus tie inverter 1 closed?
That's affirmative.
And CB EPS inverter 1 panel 11 closed. CB panel 16, instrument signal sensor closed. Inverter 1 select. Helium monitor to supercrit pressure. Report pressure to business.
Okay, that's correct. Now, step 8 is on MCC request, perform step 9. In other words, you wait for us to decide what to do, and that's according to the gouge we've already given you. And step 9 I'll give you now is helium monitor to off, inverter to off. Over.
Okay, step 8 says sit in an MCC hold. Step 9 says on MCC's words, helium monitor off, inverter off.
Roger, that's correct. Step 10 is configure circuit breaker panels per activation 3 and 4.
Okay, configure, step 10, configure circuit breakers per activation pages 3 and 4.
Roger, that's correct. Step 11 is deactivate the utility lights if you activated them. And step 12, which is the last one, is transfer to CSM power, usual observations, and report time to MCC.
Okay, step 11, deactivate utility lights. 12, transfer to CSM power, note usual observations, and report to GT.
Okay, that's it. And of course, Houston will be requesting you to go to step 9 if the pressure is less than 770. If the pressure is between 770 and 800, we will be asking you to do the following if you're ready to copy.
Stand by. Gonna find some more blank paper.
Yeah, this is going to be page TLC-3, but it's very short.
Okay, go ahead with TLC-3.
Okay, stand by 10 seconds, Fred. Fred, Houston.
Go ahead.
Roger, we'll hold off on that. It was a short 3-step procedure which said repeat activation pages 1, 1A, and 2, but there was another step in it that nobody understands. So essentially what we'd recommend in that case would be that you repeat the procedure we just passed up for reading the supercrit pressure. And if we need to, we'll clarify it later on. And that's all we got.
Yep. Okay.
It's Apollo Control, Houston, at 50 hours, 51 minutes now into the flight. We experienced some communications difficulties during that extended conversation. However, that was Joe Kerwin adding to the LIM activation procedures for the 55-hour time in the flight plan, giving steps required to get readings of the supercritical helium pressure in the LIM after Jim Lovell and Fred Hayes go inside Aquarius. Fred Hayes copied that report for Apollo 13. We now show on our displays Apollo 13 at 168,262 nautical miles out from Earth and slowing down, traveling at a velocity now of 3,463 feet per second. Continuing to monitor at 50 hours, 52 minutes, this is Apollo Control, Houston.